Hello children, welcome to my class Structure of Atom Part 5. In this session we are going to discuss Max Planck's quantum theory, Bohr's atomic model and limitations of Bohr's atomic model with neat animations. This session is developed to meet the needs of 10th class students of all boards at the same time for the aspirants of IIT, that is a foundation course for IIT. As you know that in our previous class we studied the wave nature of light, that is electromagnetic radiations travel in space in the form of waves. In the year 1901, Max Planck did various experiments and concluded that electromagnetic radiations emitted from an atom is in the form of discontinuous particles. So, we are coming from wave nature of light to particle nature of light. Let us discuss the concepts of Max Planck's quantum theory. Max Planck did so many experiments and studied the nature of electromagnetic radiations. He concluded that electromagnetic radiations that are absorbed or emitted from a charged body travels in the form of particles. It is composed of tiny particles. Tiny particles. See, observe this one. These are all the electromagnetic radiations, but they are not continuous. Observe this one. There is a gap between the particles. Observe this one. There is a gap between the particles. Are you clear about that one? So, electromagnetic radiations that are absorbed or emitted, they always travel in the form of particles, tiny particles. So, electromagnetic radiations emitted from an atom of element is in the form of discontinuous particles. Each particle of light is called photon. See this one, these are all photons. They are discontinuous. At the same time, you observe this one. These are all small particles, tiny particle. Each particle is known as photon. What we call it? Photon. According to Max Planck's theory, the smallest amount of energy that can be emitted or absorbed is in the form of electromagnetic radiations known as quantum. Observe this, each and every particle is associated with some electromagnetic radiation. That radiation or that energy, radiation is nothing but energy. That energy is known as what we call it quantum. So the energy of radiation absorbed or emitted by a photon is directly proportional to the frequency. What is that? The energy of radiation absorbed or emitted by a photon is directly proportional to the frequency. Each photon has certain amount of energy. See this one. Each photon has certain amount of energy. That is, energy of the photon is directly proportional to mu. Mu is nothing but frequency. So that is E is equal to h mu, where h stands for Planck's constant, a proportionality constant known as Planck's constant. Are you clear about that one? So according to Planck's quantum theory, the smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation is known as what we call it quantum. Quantum is nothing but the smallest energy that can be emitted or absorbed by the particles, by the photons. Are you clear? So the energy emitted or absorbed is directly proportional to frequency. Now E is equal to h mu, where h is known as what we call it Planck's constant. I told you, see this one. Let us assume a photon is there, one photon. Each photon is associated with a certain amount of energy known as photon, known as quantum. So one photon has a quantum of energy which is equal to h mu, and two photons have a quantum of energy 2 h mu. Next, three photons have a quantum of energy which is equal to 3 h mu. If you observe this carefully, energy emitted or absorbed by a photon is quantized. E is equal to h mu. It is nothing but energy quantization. We call it as energy quantization. Energy of radiation is integral multiple of h mu. Integral multiple of h mu. It is not the fraction. You observe this one, 1 hv, 2 hv and 3 hv. So this is known as quantum condition. What we call it? Quantum condition. Quantization of energy. We call it as the quantization of energy. So energy emitted or absorbed by a photon is quantized. So energy of radiation is integral multiple of h mu. Integral multiple of what is that? H mu. Here h is known as Planck's constant, mu is called frequency. Now what is the value of Planck's constant? H is equal to 6.626 into 10 to the power of minus 27 erg second. 10 to the power of minus 27 erg second, or h is equal to 6.626 into 10 to the power of minus 34 joule second. Depending on the nature of the object, electromagnetic radiation has dual nature. Depending on the nature of the object or nature of the atom of the element we considered, according to the conditions the experiment is done. So the electromagnetic radiation has dual nature, wave nature and particle nature. Later many scientists did experiments and proved the dual nature of electromagnetic radiations. In the year 1913, Bohr studied hydrogen line emission spectrum, and studied the spectrum of several atoms. Children, you observe this animation clearly. Here, nucleus is there at the center and electrons are revolving in various circular paths. After studying the spectrum of hydrogen atom, in the year 1913, Niels Bohr proposed his atomic model. You observe this carefully. Few electrons are revolving slowly and few are revolving very fastly. The electron which is very nearer to the nucleus is moving slowly. Observe the slow motion of the electron when compared with the electrons that are away from the nucleus. So in the year 1913, after careful studying of hydrogen spectrum, emission spectrum, Niels Bohr proposed his atomic model in the year 1913. As for his theory, atom is spherical in shape. Observe this one. Atom is spherical in shape and the positive charge is concentrated at the center known as the nucleus. This was also proposed by Rutherford. Next, electrons revolve around the nucleus with high speeds in various circular paths known as energy levels, or we call it as shells. This is first shell, this is second shell, this is third shell, and this is fourth shell. They are denoted with n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and so on. R, K, L, M, N, and so on. Are you clear about that one? So he proposed that electrons are revolving around the nucleus with high speeds in circular orbits. Next, another important thing he proposed, see this one. Electrons revolve around the nucleus with high speeds in various circular paths known as energy levels or shells. As long as the electron, observe this one, as long as important point, as long as the electron revolves in its fixed orbits, its energy remains constant. As long as the electron present in the first shell is in the first shell, its energy remains constant. The electron which is moving in the second shell, as long as revolves in the second shell, its energy remains constant. Next, the electron which is moving in the third shell, as long it revolves in the third shell, it remains constant. Its energy remains constant. The electron which is moving in the fourth shell, as long as it moves in the fourth shell, its energy remains constant. So, as long as the electron revolves in its fixed orbits, its energy remains constant. What do you mean by orbit? It is the path followed by the electron round the nucleus. So they are called stationary energy levels. Why they are called stationary energy levels? As long as the electrons revolve in their fixed orbits, its energy remains constant. So they are known as stationary energy levels and are denoted with KLMN. Observe this animation, children, very clearly. Okay, so you can understand the concept very clearly if you observe this animation. Now see this one. Another important point, postulate given by Niels Bohr. Observe this. When certain amount of energy or radiation falls on the atom, the electron absorbs the energy and electron jumps to higher energy level. Observe this one, higher energy level. The electron is moving from the ground state to the higher energy level. Okay, next, but the electron cannot stay in the excited state, higher energy level. This is known as the excited state and this one is known as the ground level. So the electron cannot stay in the excited state and it comes back to its ground state. When it is coming back to its ground state, to its original state, the difference in the energies E2 minus E1 is radiated in the form of electromagnetic radiations. Observe this one, observe this carefully. Okay, so energy is radiated. When this energy or when this radiation is caught on the screen, you will find colored lines on the black background with the black background. Are you clear? So this is an example for emission spectrum. Okay, emission spectrum only gives the colored lines with black background or dark background. Are you clear about that one? How the energy is emitted? When an electron moves from ground state to the excited state. How it is moving, why it is moving? When sufficient amount of energy is given, maybe the photon or maybe some energy is given, this energy is absorbed by the electron present here and it jumps to the excited state. But in the excited state, the electron cannot stay for longer time. Its time period is in nanoseconds only. Immediately it comes to its ground state. So when it is coming from excited state to ground state, the difference in the energies is radiated in the form of electromagnetic wave or electromagnetic radiations. When these radiations are caught on the screen, okay, we will observe colored lines with dark background. So the spectrum of hydrogen atom is an emission spectrum. Are you clear about that one? Why the energy is emitted? Why the electron goes to a higher energy? You can understand very clearly with this animation. Observe this carefully. Energy is given, sufficient amount of energy is given, maybe the photon or maybe the light energy, some energy is given. Okay, that energy is received by the electron present in the ground state and reaches to the excited state. But in the excited state, the electron cannot stay for longer time. Its time period is nanoseconds only. It returns back to its ground state. When it is coming back, it radiates energy. It is in the form of electromagnetic waves. When these electromagnetic radiations are caught on the screen, we will find colored lines with dark background. So this is an example for emission spectrum. So why energy is emitted? When electron jumps from higher energy to lower energy, the difference in the energies is emitted in the form of electromagnetic radiations. That is E2 minus E1 is equal to h mu. E2 minus E1 is equal to h mu. Children, you observe this animation. Electron is jumping from excited state to ground state. Okay, why it is jumping? Electron cannot stay longer time in the excited state. It has to come back to the ground state or to its original state. The difference in the energies is emitted in the form of radiation. In the form of radiations. When these radiations are caught on a screen, the screen looks like spectrum with certain gaps. We will find a spectrum with certain gaps. Observe this one. There are the gaps between the colored lines. Observe this carefully. So this is the, what is that? Emission spectrum, and this is discontinuous, not continuous, discontinuous. See, lines are there. Okay, they are separated by some distance. There are the gaps. When an electron is jumping from excited state to ground state, the difference in the energies is emitted in the form of electromagnetic radiations. It can be clearly seen on the screen with black background, and colored lines are formed with gaps between them. Observe this one. When an electron jumps from lower energy state to higher energy state, it absorbs energy. It cannot stay there for longer time. When electron jumps from higher energy state to lower energy, it emits energy. The energy emitted by an electron is equal to E is equal to h mu. Next, the fifth condition, the angular momentum of the electron in an orbit is equal to nh by 2 pi. Here angular momentum is quantized. MVR is nothing but angular momentum is equal to nh by 2 pi, integral multiples of h by 2 pi. Why the angular momentum is the integral multiple of h by 2 pi? He cannot explain. Bohr failed to explain this condition also. Next, another limitation for this one, for Bohr atomic model. Observe this one. When the spectra is seen with the powerful spectroscope, these lines splits into smaller units. Observe this one. The red line splits into only one, but whereas the yellow one splits into three simpler units, three smaller lines, and whereas this green splits into five smaller lines. So the splitting of spectral lines are the fine spectrum. We call it as the fine spectrum. He failed to explain the splitting of spectral lines. So it is one of the limitation of Bohr's atomic model. Bohr successfully explained the spectrum of hydrogen atom, but failed to explain why the angular momentum is quantized. Next, another one, what is that? Splitting of spectral lines. He failed to explain why the splitting of spectral lines is taking place. Let us discuss the limitations which we have seen in the animation. Limitations of Bohr's atomic model. It does not explain the spectra of atoms having more than one electron. It does not explain the spectra of atoms having more than one electron. Next one, it could not explain the splitting of spectral lines in the presence of magnetic field. This effect is known as Zeeman effect. Another one effect is also there, you will learn in your higher classes, that is splitting of spectral lines in the presence of electric field is known as Stark effect, whereas in the presence of magnetic field is known as Zeeman effect. He failed to explain the Zeeman effect and Stark effect, which you will learn in your higher classes. Next one, failed to explain why the angular momentum of the electron in the orbit is quantized. MVR is equal to NH by 2 pi. Why it is equal to NH by 2 pi? He failed to explain that one. These are the limitations of Bohr's atomic model. Children, I think I made crystal clear the concept of Bohr's atomic model and limitations. Next, what is emission spectrum, why energy is emitted, why energy is absorbed, why the electron moves from ground state to higher energy state, why it comes back to higher energy state, that is excited state to ground state. I hope I made the concept crystal clear. Children, for watching my lesson. If you like my videos, do subscribe to my channel Mathocity. You will get immediate notifications when you subscribe to my channel. Thank you once again.